because he just, all of his language is so statistics based that like if you don't know anything about statistics, then like the expected value of the probability of 20 balls means absolutely nothing. Like, I don't know what that means.
You're not recording it right now.
Oh, are you?
No,
I don't know what that means.
we're not recording.
I just recorded. Like not for the first few minutes. So
I'm just confused on how to interpret what he says in class as like something that someone who doesn't study statistics would understand.
yeah. I mean that could be true because when I was taking this class, I mean a lot of students from the class complain about like there's not too much concrete examples during the class.
Literally.
That is a pretty succinct summary of our experience at this point. The consistent lack of examples. And I think there's a handful of ball examples that are like mediocre. I think what we're looking for are real world examples where like we feel like we can apply this. That would drive material excitement and interest in the content.
And like if you gave us 5 examples that then you gave us homework and we could say, oh, these are similar, so I know how to apply this. But like looking at the homework right now, based on what we talked about, I don't know which one to apply because I don't have examples to understand what everything means. Like that's where I'm struggling is like, I'll look at a question. I'm like, I don't know how to solve this because I was never given an example of how to solve a problem. I was just told theoretically that this could happen, and I don't know how they apply together.
Yeah.
But I'll stop talking because we're recording.
Yeah, it's pretty common actually. So don't be too stressful. And also, like you guys could mention that during the lecture, and maybe ask the professor to give you some examples about what you just talked about. And also, the professor is pretty smart, and I believe he can come up with a concrete example pretty quickly.
Okay, that's good. That's good feedback. Like we haven't actually tried that, so even if he isn't providing examples organically, I'm more than happy to prompt him to do so.
Okay, sure. And I've just looked at the third question of the homework. I share my screen.
Okay.
Can you see the screen now?
Yeah.
Okay, sure. So basically, I think it means like so buying stuff from the restaurant, you have a chance of winning. And the chance is evenly distributed to all the food and drink in this restaurant, and the probability was 1/20. So that means if you buy a drink or if you buy French fries or anything else, but the quantity was 1, like you buy 1 drink or you buy 1 French fries, you get the 1/20 probability of winning the prize. Okay, so if I ask you,
is the probability not then 7 out of 20? I get 7 independent.
No, it's not 7 out of 20 because because for part A, the question is asked like what is the probability of winning at least once. Okay, so this wording means it's pretty hard to find this probability through a forward attempt. A forward attempt, I mean, you just calculate the probability of winning by buying 7 items. Because the probability would be here in the case would be I win once and I win twice and I win 3 times all the way. I'm still possible to win 7 times of buying 7 items. So to calculate those 7 probabilities and adding them up could be very complicated.
But so what makes it 7? What makes it 1 out of 20 as opposed to, because like when we did the coin flipping one, right?
Yep.
It was 1/2 to the 20th. So why is this one 1/20 instead of 1/2 to the 20th? Because you still have half of you either win or you don't win, and you're
Like
doing 20.
Because here the probability was 1/20. When you're tossing a coin, the probability of getting a head and getting a tail are both 1/2, right? But here, this is the policy of the restaurant. They just said when you buy an item, you have 1/20 probability of winning a prize.
Okay.
So for part A, I think the best way is to think back forward. What do I mean is we can find the complement of the statement of part A, right? They want us to find the probability that someone wins at least once. Someone wins, given that they buy 7 items.
We find the combined probability that someone doesn't win. Was it 13? Or no?
Yeah, 13.
No.
It's the 7.
No, 19 don't win and 1 wins.
Right. So if you find out, the question is the combined probability of the 7. So if you figure out 19/20 is the chance that you don't win.
Yes,
and
that's correct.
You multiply that, I guess, 7 times together.
Yes.
That would be like the chance of not winning
in consecutive 7 trials.
Right.
The chance of not winning.
The odds that I don't win at all.
Yes.
7 times in a row is 7 times 19/20.
No, it's not 7 times 90/20, but instead it's 90/20 to the power of 7.
Why?
Does that make sense? Because the first time I don't win, what is the probability?
Oh, sorry. Yes.
So every time my probability of not winning was 19/20. Yeah.
You're multiplying 19/20 by itself. Yes.
Yeah.
Yes.
So the probability of not winning in consecutive 7 trials is given by 19 divided by 20 to the power of 7. But here, my question is, what is the probability of winning at least once? So you should use 1 minus the probability of not winning. And that would be the answer of part A.
So it's 1 minus 19/20 to the 7th power.
Yeah, or 19/20 multiplied by itself 7 times.
Okay.
Which makes sense.
So, but then where I'm confused though is that's not the hypergeometric model, right? That's not the binomial probability model.
I would say it's a binomial probability model because it's pretty similar to like tossing a coin. If I just ask you what is the probability of getting 7 consecutive heads, and you will give me, okay, it's 1/2 to the power of 7. And here it's like the same thing, but we are just thinking from the back to the beginning. I'm thinking like, what is the probability of not winning once, not winning even once? And my probability was not winning to the power of 7. So I would argue it is actually a binomial distribution. And but what we are doing differently is here I'm considering what is the probability of not winning instead of getting forward to the question directly.
But so, I mean, if you do that calculation, your probability of winning is 0.
Is it?
1
No.
minus 19 over 7 raised to the 7th power.
Isn't it 1 minus 0.698? So then
Yeah, it's 40 something.
Yeah, it's
30,
40.
30.
What's 0.698?
is 19 over 20 to the 7th power.
Oh, it's 19 over 20 to the 7th power, and that's subtracted from 1.
Yeah,
Yeah.
exactly.
Okay.
And Olivia, the concept of binomial distribution is that there is two outcomes, and it does not force that those outcomes are equally likely. I mean, there's the convenience of the coin flip is that it's more simple, but you can have unequally likely outcomes in a binomial distribution,
Yeah.
which is what this is.
So the part that I'm confused about that though is like the binomial distribution calculation is n factorial, right? Then n minus k factorial, all that stuff.
That is the formula in order to answer a very specific question, which is what is the likelihood of n trials and k tosses? This is asking a different kind of question. So you're still using the same distribution, but you're asking a different question of that distribution. And in this case, this is like, there was a part of the lecture last week where he was talking about like the complementary pieces of a probability. I'll try to find the slide actually. It's actually, I think, an easier concept than like this n choose k thing. I think you'll find it. Sorry, you have it up. Let's see. Yeah, so slide 17.
Okay.
Unions, intersections, and complements. A pretty theoretical slide. But it talks exactly about this, where you're kind of taking like the opposite and the intersection of certain events, and it allows you to deconstruct the problem in the way that Victor did. Victor, can you validate everything I just said?
Yeah, I think you made a pretty good point. And Olivia, I think you just struggled about like this formula, right? This is what you're talking about, like factorial stuff.
I'm fine with that calculation as
Yeah.
long as like where I'm struggling is I don't have any indicator at the moment to know not to use that formula, because the statement that kind of came up was, okay, binomial distribution is the basis for pretty much all of the scenarios, right?
Yes.
Like the geometric, the Poisson, like all of that stems from the binomial. So I'm fine. I have no issue being wrong, and I'm happy to learn it. I'm just struggling to, I don't know where, but I think your point, Oliver, was like based on the discussion we had in class, I guess like you would have to infer from the last slide how to get there, I guess.
Okay, so first, to answer your question, you can use this formula here, because that is a formula for binomial distribution. But look at this question. What is this formula for? It's to solve the question, what is the probability of observing exactly k heads in n tosings, right? So what is the homework problem? If I thinking back forward, the question would be, what is the probability of observing exactly 7 not winning in 7 trials, right?
Yeah. Okay.
So you can apply this formula here. Definitely, you can apply to this formula. And the probability of not winning is simply 19 over 20 instead of 1/2 for tossing coins, right? And the probability of winning is 1 over 20. But notice here the p to the k n and 1 minus p to the n minus k power. Here the k would be 7 and n minus k would be 7 minus 7, which equals 0. So it's the probability of winning to the power of 0, and anything to the power of 0 equals 1, right? So that's why when I do this home assignment, I didn't use the probability of winning the prize, because ultimately it would equal to 1, and doesn't impact my process of solving this problem. And yeah, so my answer would be yes, you could use that formula, but here you have like more intuitive way, because you want to get like 7 consecutive not winning out of 7 trials. So basically the probability of not winning would be 19 over 20 to the power of 7. Okay.
Okay.
Sure.
So, Victor, I've been thinking about part B for a little bit.
Yeah.
I have a thought that I'd love for you to validate. The formula that we have set up for part 1, we're saying 19 over 20 to some number of attempts is the inverse of our success.
Yeah.
Well, in this case, success and failure, like it's 50%, right? So really, like the inverse of success will be the same as the inverse of failure, which is 50, right? We're solving for 50%.
Yes.
So in that case, our odds of success or our odds of failure, like you can go about it either way. Just to stick with the same formula. So we have 19 over 20 to some unknown number of selections is equal to 0.5 is the formula that I've set up. Does that sound like the right approach?
Yeah. Yeah. Great.
Okay, but then in order to solve for that, because we have an exponent
Like I
variable.
don't anticipate you to solve that, but again, like
Wait,
to
what do you
make that
mean? We have to
obvious
solve.
clear, I will not say like 19 over 22 nth power equals 50%, because in reality it's not equals to 50%. Like this question asked me to have at least a 50%
No, it
chance.
doesn't. I specifically read that. It does not say at least. It says a 50% chance. So that the number that's going to come out is going to be a fractional number of purchases, which is kind of silly. Like based on the exact phrasing of the question, it demands a fractional number of purchases. If the phrasing of the question said at least, then yes, we would have to get to a whole number of purchases. But do you see the difference?
So are we allowed to use Excel or a calculator?
Hold on. I want to know the answer to this. Do you see the phrasing difference?
I saw the difference, but I would argue you should add at least in this question. So this is
Okay.
how you comprehend this question. In order to have a 50% chance means in order to have at least 50% chance.
Okay, the question then becomes a little bit easier because you can run through, you can just start at 1 and you can work your way up.
Yes.
And come to
That is
an
true.
outcome
That is true.
greater
You
than.
can start obviously over 7
trials.
Yeah,
that's very educated conclusion.
0.3.
Yeah.
I would start with maybe 9 trials.
Yeah.
And see where that goes.
And we can use Excel, or do we use a like calculator? I think he said
anything
in the
is
test
fine. Anything is fine. But I think like during the exam, you are only permitted to use a calculator. Maybe I'm not sure, but
okay.
Yeah.
No technological.
Yeah.
So. Okay.
But for me, like instead of putting an equal sign, I would say like 1 minus 19 over 20 to nth power is greater or equal to 50%. And then I'll try the number in that like 19 over 20 to the nth power, right? And then I'll try n from 7. And I say like on which n my probability is greater than 50%. And that would be my number.
So I just plugged into the calculator 19 over 20 to the 9th power and I get 0.6. So I can maybe just go one down and like help myself out, but maybe to the 8th power and
Yeah, exactly.
and just
That's
see
exactly what it is.
what's
That's exactly
closest.
the approach.
Okay.
Okay.
But just so I understand the thought process, the way to get question A is the probability of you not winning the 19 over 20 times however many times you do it. So the probability of you not winning times you bought 7 fries, then the probability of you winning is just 1 minus the probability of you not winning 7 times.
Yeah, exactly right.
And then in part B, you're saying what you have a 50, how do you get a 50% probability? How many fries do you need to buy?
Yeah,
And you say, okay, well, the only way to do that is with a calculator. With a calculator, you can figure out, I did it on Excel and it's about 13 and a half. So you have to buy 13 and a half French fries and drinks in order to, you can't buy half a drink. So I guess Oliver, he's right. You'd have to buy 14, which would be greater than.
yeah, your number should be an integer.
Yeah, because it's still 19 over 20.
If you
the
have 1 over
losses.
20,
Yeah.
then that would work.
Okay.
So yeah, either way. We used Boole's inequality to solve A, right? Like we nothing to read. Like that's exactly what we did, right?
Yeah.
And so the final question is asking something that's more qualitative, right? It's just saying like provide an opinion on whether we think it'll work well. But I think like if we got to an answer that yes would be the answer, right? Like it feels like it's the best way to get to it, not just work well.
So the right hand side of that inequality, probability of A1 plus probability of A2 plus etc. to probability of AN. What do you think that right hand side in this particular example?
So in this case, it's the probability that you win if you place one order.
What is that?
1 over 20.
And then the probability of you win by buying only the second order. Your winning chance is still 1 over 20, right?
Right.
So here the left hand side, what's the number in right hand side? You buy 7 items.
Sorry, repeat the question.
So for that inequality, what do you get in the right hand side?
You would
1 over 20 7 times.
Yeah,
No.
That's correct. That's correct. Because you are finding the probability of winning the prize by buying the item 1, and then you plus the probability of winning the prize by only buying the item 2, and all the way to the probability of winning a prize by only buying the 7th item. So on the right hand side, it would be 7 over 20. And the left hand side, if you can understand that notation, the left hand side is actually the answer from part A. So that is just the probability of all the items and you union those. So that means at least you win 1 prize. And actually you'll find that your answer in part A would be pretty close to 7 over 20. It would be pretty close to the right hand side.
Wait, I'm sorry. Can you repeat what does the left-hand side mean? I missed what you said.
Okay, so here, A1 means I buy the first item and I win the prize. So what is the probability of that?
Yeah, 1 in 20.
And A2 means I buy the second item and I win the prize. The probability is simply 1 over 20 again, because I only buy the second item, and that's 1 item.
Okay.
All the way to A7, which means the probability of I win the prize by only buying the 7th item. And that's again 1 over 20. So you sum them up, and that would be 7/20.
Okay. And that's what the right side means, right?
Yeah.
So how is it different than the left side?
What do you think about the meaning of the left-hand side?
I have no idea.
It's just the probability of winning by only buying the first item, union the probability of winning by only buying the second item, union. So so you should understand what this notation like union, union intersection. So basically that means you win the prize at least once. So that is the answer from part A.
Huh, okay.
And that probability was actually lower because I have I think it's a pretty interesting and intuitive example.
So it's the probability of winning it at least once versus the probability of 7 orders and winning it in one of the 7 orders?
Yes, that's true. But
oh,
so here's my example, right? Like if you go buy lottery, right? I assume like the probability of winning the lottery is 1%.
Mm-hmm.
If you use the right-hand side to calculate the probability, I have a claim that if I buy 100 lottery, my probability of winning would be 1. This is how I calculate using the right-hand side, because every time my probability was 1%, and I just sum them up 100 times, it would be 1. 100% would be 1. But in reality, intuitively, you will understand that if the probability of winning a lottery is 1%, even though I buy 100 lotteries, I still have a chance of not winning the prize. So in reality, the probability would be close to 1, but smaller than 1. So that's how to understand this inequality intuitively.
Okay. That makes sense. Thank you.
Yeah.
I also have a question. I don't know if someone already asked this and maybe I missed it, but the professor said that the homework was due Tuesday, and I think there's a lot of confusion on when it's actually due. Do you know?
I don't know either, but given that like I am the one who receiving all the homework, I would say you are good to submit the homework until 6 p.m. On Wednesday. Like I don't have too much communication with the professor, so
Okay.
yeah, so I don't know. I think he like didn't mean to collect all the homework before Tuesday, I think. And also like given that I'm holding the office hour on Monday night,
Yeah.
and you guys have work on Tuesday, so I really do not think like you guys have to finish the homework on Tuesday. So I think just any time before class is okay.
Perfect. Thank you.
Sure.
Thank you for asking that, by the way. What is the preferred submission format? Can we scan something we've handwritten and upload that? Is that okay? Would you prefer something typed out? What is your preference?
Definitely, it's okay to like handwrite all the homework, because like especially later this semester, you will use like many weird notations, and it's very difficult to type those notations. So
Yeah,
definitely, you're free to like handwrite all of the homework.
Okay, wonderful. Thank you.
Sure, but like I like anticipate you guys submit the homework through one PDF file, so
Sure.
it's easier for me to like grade and view. Yeah.
Absolutely. Yeah. I definitely can scan it, but wanted to
Sure.
make sure we could
Sure.
handwrite it first. Cool.
So do you have any other questions or?
No.
I don't
Yeah.
think so. All right.
Yeah, like the homework was a little bit challenging, and even in when I was taking this class, like the teaching fellow was not so responsible. Like no matter how you perform on the homework, he just gave you a random score or something. So yeah, it's pretty challenging, and I understand that it's more quantitative than other course you're taking this semester, but just try your best to understand these questions, and like I will give partial credits for your thoughts, so write down as much as possible. And if you don't have any more questions, I think we can stop now.
Oh, I have a question.
Okay, go ahead.
Sorry. Question 2.
Okay.
I think I was doing this the wrong way. I was kind of looking at it by that like hypergeometric way.
Yeah.
Well, so do you have the hypergeometric formula up?
Here on the slide, I guess.
Yeah, do you have the slide? Because the part where I'm confused
Wait a
again
second.
is like how do the two formulas interact with each other? The top part that's the red over red plus blue
Yeah.
versus like the probability of selecting J. Like I don't know if we maybe went over this in class, but I mean I did a little bit of research and it looked like the bottom part of the slide was like you would do however many, in this case, red balls factorial over however many you're going to select factorial times however many black balls factorial over, you know, the number of trials you're doing and all that stuff. So I guess I'm not really understanding how that interacts with like, or should we just be doing?
So you understand this second formula, right?
I don't see anything on your screen, but I can share it if you need me to.
Okay. You
I see
cannot
the
say
PDF.
things on the screen, right? So you cannot share my shared screen.
I see the PDF. I don't see any of the equations.
Okay, I'm sorry. Maybe I will. I'll try like stop sharing and share again. Can you see this now?
Yes.
Okay, sure. So you understand this second formula, right?
So
From
that
the
just means
description, I think. Oh, sorry.
that
This
just
one?
means that like if you have, I think that makes sense because your probability of pulling a red ball is just however many reds over the total balls. And then what's your probability of picking 2 of them? It's the same the first probability is the same and the second probability is just, you know, the same, just -1 because you've already taken one red ball out. But so then how do you, what is the bottom formula kind of telling you?
So basically, you don't need to think about factorial. You don't need to calculate what is R choose J, right? So first, you need to understand this formula in this setup, in the R choose J times B choose N minus J divided by R plus B choose N. So the probability of the setting, of any setting, is simply how many ways I can satisfy these specific settings. divided by the total way I can choose from the whole problem, right? So if we draw n balls from R plus B total balls, right? So here under the fraction, I hope you understand what does that mean. That is like R plus B is the number of balls, and I need to choose n balls from R plus B balls. So that is just R plus B choose n. That is the total way, how many ways I can draw n balls, no matter the color. Okay?
But so that's R plus B over N as a fraction, right?
It's a choose. R plus B choose n. It's a combination. I think like I mentioned in the Sunday session.
Okay.
It's you could watch the recordings, or I'm not gonna prove that again, but the
I'll watch the
professor,
recordings.
yeah,
That's fine.
the professor stated here, this is the formula. Like in the Sunday session, I just went through how to prove this formula. That is unchoose k means, what does that mean? That means how many ways I can choose, for example, 2 people from 10 people. How many ways, right? I have 10 names and I can circle at random 2 names. There's how many ways I can do this. I can choose the first 2, I can choose the first and the third, I can choose the middle 2, I can choose the last 2, etc. This just gives us a way to calculate how many ways I can choose k from n. So,
Okay.
so in this formula, here is how many ways I can choose n balls from R plus B balls. This is the total ways to do that. And in the numerator, and here in the upper side, I'm going to calculate how many ways satisfy the setting. In this problem, the setting was I draw n balls and I get exactly j reds. And because of I get j reds and I draw n balls, I automatically draw n minus j black balls. So this is my setting. I draw n balls in which j was red and n minus j is black. So how to choose j red balls? How many ways I can choose j red balls? It's just r choose j, because r is the total number of red balls. And again, how many ways I can draw n minus j black balls? It's b choose n minus j, because I have b black balls in total, and I need to draw n minus j black balls from the total. And it's just b choose n minus j, and I multiply them together. And you could watch the recordings on how do we get this formula and choose k. So basically this one here is pretty similar. It's pretty like easy set up, but actually if you want to calculate this, you should calculate r choose j, b choose n minus j, and r plus b choose n, and all of those include some factorial things. It's like for n choose k, it involves actually 3 factorials, and presumably you have to calculate that using a calculator.
Got it.
So like for home assignment number 2, the question number 2, it is a hypergeometric model, and again you will need to use the uh, back forward thoughts. Like you will try to understand what is the probability that I couldn't find the enemy through 15 consecutive tries. Uh, like the idea was pretty much like the third problem we just discussed, but it's a hypergeometric probability, meaning that it's not that easy to just use 19 over 20 to the power of 7. No, but it's like this formula here. Every time my probability is changing. So basically that is the idea of question 2.
Okay. Got it. Thank you.
Sure. So I'm gonna stop recording.